Hello, welcome back to my channel. In this video, I'm going to show you how to use binomial expansion to estimate a value. If this is your first time here and if you want to upgrade your math skill and boost your grade, make sure you subscribe my channel by hitting the subscribe button below so that you won't miss anything. If you find that this video is useful, please hit the like button below. So, let's start the lesson right now. In this video, I am going to show you how to use binomial expansion to do estimation. Now, let's look at this question. Expand 8 plus 4 over x power 1 over 3 in ascending power of 1 over x up to the term 1 over x power 3. State the range of x such that the expansion is valid. Hence, approximate the values of the following correct to 4 decimal places. Before doing the expansion, we must make sure that we are ready to do the expansion. That is, if the power is not a positive integer, where if it is a negative or if it is a fraction, then the first number here must be equal to 1. So, after we have made sure that it is equal to 1, means we are ready to do the expansion, then we can use this formula to do the expansion. When we look at this question, I notice that we are not ready to do the expansion because the power here is a fraction, which is 1 over 3. And the first number is not equal to 1. So, first thing we need to do is we need to change the first number becomes 1. That is, we factorize the 8 out here. So, after factorize, we get 8 multiply 1 plus 4 over 8x power 1 over 3. Then we separate the index. We get 8 power 1 over 3 multiply 1 plus 1 over 2x power 1 over 3. Then 8 power 1 over 3 is equal to 2. Up to here, now we are ready to do the expansion because the power is 1 over 3 and the first number here is equal to 1. So, based on the formula here, now when doing the expansion, so according to the formula, first number is 1 plus n is 1 over 3 times fx. Fx is 1 over 2x, then plus n minus 1 over 2 factorial, fx power 2, then plus n is 1 over 3, n minus 1, n minus 2 over 3 factorial, fx power 3. After simplify, we get the expansion here. Then finally, we expand the 2 and the final expansion is this one. Now, after we have got the expansion, now state the range of x such that the expansion is valid. So, for the expansion to be valid, the modulus of f of x must be less than 1. So, in this case, f of x is 1 over 2x. But one of the common mistake of the students is students always take this one 4 over x as fx. So this is definitely not correct. So because this binomial expansion, the power is 1 over 3. If the power is 1 over 3, so the first number must be changed to 1. So after we change to 1, so fx is this one. So now modulus 1 over 2x less than 1. In order to find the value of x, first we turn the 1 over 2x becomes 2x. When we turn, the direction of the arrow here must be turned, becomes modulus 2x greater than 1. Next, we need to clear the modulus sign. When we clear the modulus sign, we will get 2x less than -1 or 2x greater than +1. Then from here, we get x less than -1 over 2 or x greater than +1 over 2. This means that the expansion is valid if x is less than -1 over 2 or if x is greater than +1 over 2. Next, I'm going to use this expansion to find the approximate value of cube root of 1.12. So in this case, I need to find a suitable value of x to be substituted into this equation. Now when I look at these two values, I found that both are power 1 over 3. So means I can compare these two values. From here, I try to find the values of x. So when I simplify, I found that x is 25 over 6, which is 1 over 6. So means I can use this value to substitute into the equation. But before this, we must confirm that this value is in the range of value of x, where the expansion is valid. So when I look at here, 25 over 6 is greater than 1 over 2. So here we confirm that 25 over 6 is in the range of value of x, where the expansion is valid. So now I'm going to substitute x equals 25 over 6 into the expansion. So now I substitute x with 25 over 6 into the expansion. Now I try to simplify the calculation on the left and on the right hand side. Then I get 2 multiply 1.12 power 1 over 3 is approximate to 2.07541. Then now I shift the 2 to the right hand side. Then I get the cube root of 1.12 is approximate to 1.0377. Now question number 2, we are going to use this binomial expansion to find the approximate value for cube root of 8.12. When we look at these two values, even though both values are under the power of 1 over 3, but we can see that the values are great different. For this binomial expansion, we know that for the expansion to be valid, the value of 1 over 2x must be less than 1. So therefore, the total value for 1 plus 1 over 2x is approximate to 1. Compared with 8.12, they are great different. So in this case, we need to reduce the value 8.12. So what we need to do is, we can separate 8.12 into two numbers a and b, where a multiply b is equal to 8.12. So in this case, there are many combinations of A and B such that A times B is equal to 8.12. So in this case, we need to choose the suitable values of A. Since the number here, the power is 1 over 3, so 1 over 3 means that is a cube root. So the suitable number chosen for A should be a cube number. So they are either 8 or 27 or 64 and so on. As for the value of B, we can simply use 8.12 divided by the value of A. Since we are going to use the binomial expansion to find the approximation, so the value of B should be approximate to 1. So here we found that 8.12 divided by 8 is approximate to 1. So therefore, I can change cube root of 8.12 into 8 times 8.12 divided by 8, power 1 over 3. Now I separate the index, and when I simplify, I get 2 multiply 1.015 power 1 over 3. So now I can use 1.015 to compare with 1 plus 1 over 2x. And when I simplify, I get x is 100 over 3. So when I double check with the range of values of x, I found that 100 over 3 is in the range of values of x where the expansion is valid. So now I'm going to use these values of x to sub into the expansion here to find the approximate value of the cube root of 8.12. So now I substitute x with 100 over 3 in the expansion. Now when I simplify both sides, I get 2 multiply 1.015 power 1 over 3 is approximate to 2.0099. From the calculation just now, I found that 2 multiply 1.015 power 1 over 3 is same as cube root of 8.12. So therefore, from here, then I get the answer for cube root of 8.12 is approximate to 2.0099. Now question number 3, I'm going to use this binomial expansion to find the approximate value of cube root of 65. Now when I compare these two values, even though both are under the power of 1 over 3, but the values are great difference. So now what I'm going to do is, I'm going to separate 65 into two numbers A and B, where A multiply B is equal to 65. Since there are so many choices where A multiply B is equal to 65, but we must choose the correct value. Now first we start from A. Since 65 power 1 over 3 is cube root of 65, so the A here must be a cube number. So we can choose either 8, 27, 64 and so on. As for the B, we simply use 65 divided by the A. From these options, we must choose the value of B where the value of B is approximate to 1. So we notice that 65 over 64 is approximate to 1. So means we can choose this combination. So here I change 65 becomes 64 times 65 over 64. So when I separate the index, I get 4 multiply 65 over 64 power 1 over 3. So now I can compare 1 plus 1 over 2x with 65 over 64 because the value of 1 plus 1 over 2x is approximate to 1 and 65 over 64 also approximate to 1. So when I compare these two values and when I simplify, I found that x is equal to 32. So once again, I need to double check whether x equals 32 is in the range of value of x where the expansion is valid. So when I see here, I found that x32 is in the range of values of x. So now I can substitute these values of x equals 32 into the binomial expansion to find the cube root of 65. So now when I substitute x with 32 and when I simplify left hand side and right hand side, I get 2 multiply 65 over 64 power 1 over 3 is approximate to 2.01554. From the calculation just now, I found that cube root of 65 is equal to 4 multiply 65 over 64 power 1 over 3. So now I separate the 4 into 2 times 2. Then from here, I can substitute 2 multiply 65 over 64 power 1 over 3 with 2.01554. Therefore, I get the cube root of 65 is approximate to 4.0311. Now let's try another example. Expand cube root of 1 minus 3x over 1 plus x in ascending power of x up to the term x power 3. State the range of x such that the expansion is valid. Hence, approximate the value of 1 over cube root of 3, correct to 4 decimal places. Now when we look at this question, actually this question involves two binomial expansion. One is power positive 1 over 3. The other one is power negative 1 over 3. Before starting the binomial expansion, we must always double check whether we are ready to do the expansion. That is, if the power is not a positive integer, the first number must be equal to 1. So we find that both binomial expansion are ready to be expanded. So based on the formula for the first expansion, fx is negative 3x, n is 1 over 3. So when I substitute into the formula, then I'll get, this is the first expansion. As for second expansion, fx is x, n is negative 1 over 3. So when I use the formula, then I'll get this expansion. Now I'm going to simplify these two expansion. So after simplify, I get these two expansion. Now again, I try to expand these two series, and when I simplify, then this is the series expansion of this question. Now I'm going to find the range of values of x such that the expansion is valid. Since this series involving two binomial expansion, so we must calculate the values of x one by one. So for the first binomial expansion, 1 minus 3x power 1 over 3. The expansion is valid when 3x less than 1. Then from here, we get x is greater than negative 1 over 3 and also less than positive 1 over 3. As for the second binomial expansion, we found that x is less than 1. So from here, x is greater than negative 1 and less than positive 1. Now when we combine these two sets of values of x, we found that the range of values of x for this expansion to be valid is the values of x must be greater than negative 1 over 3 and less than positive 1 over 3. Now I'm going to use the binomial expansion to find the approximate value of 1 over cube root of 3. Now when I compare these two values, I found that the cube root cover the both numerator 1 minus 3x and denominator 1 minus x. But 1 over cube root of 3 only, the cube root only cover the denominator. So now I change 1 over cube root of 3 becomes cube root of 1 over 3, such that the cube root cover both numerator and denominator. Before I continue, I must make sure that the value in the cube root here and the value of 1 over 3, the values are not great different. And under binomial expansion, we know that 3x must be less than 1 and x must be less than 1. So I can see that the total value here is approximate to 1. It is around from 0 to 1. And cube root of 1 over 3 also, the value is from 0 up to 1. So the values in these two numbers are not great different. So therefore, I can compare these two values where 1 minus 3x divided by 1 plus x compared with 1 over 3. Then from here, I find that x is equal to 1 over 5. Once again, I need to confirm that, and I need to make sure this value is in the values of x such that the expansion is valid. So I found that 1 over 5 is in the range of x where x is greater than negative 1 over 3 and less than positive 1 over 3. So now I can use these values of x to substitute into the binomial expansion here. So when I substitute, then I substitute x with 1 over 5 on the left and also on the right. Then I try to simplify. On the left hand side, I get cube root of 1 over 3, and on the right hand side is 0.7284. And we know that cube root of 1 over 3 also same as 1 over cube root of 3. So therefore, the final answer is 0.7284. Now let's look at this question. Expand 1 over square root of 4 minus x squared into ascending power of x up to the term x power 4. State the range of x such that the expansion is valid. Hence, approximate the value of square root of 15 over 15 correct to 4 decimal places. When we look at the question, we found that we are not ready to do the binomial expansion because the power is not a positive integer and the first number is not equal to 1. So what we need to do is we need to change the first number into 1. That is, we factorize the 4 becomes 4 multiply 1 minus x power 2 over 4. Then when we simplify, we get 1 over 2 multiply 1 minus x squared over 4 power 1 over 2. Now we shift this one going up and we get 1 over 2 multiply 1 minus x squared over 4 power negative 1 over 2. Now we are ready to do the binomial expansion. So by using the formula, n is negative 1 over 2, fx is negative x squared over 4. Then followed by n minus 1 over factorial 2, fx power 2. When we simplify the expansion, we get this. Then again we expand the 2. Then finally we get this expansion as the answer. Now I'm going to find the range of values of x such that the expansion is valid. So for the expansion to valid, so we know that x power 2 over 4 must be less than 1. And please make sure that we take this from here. Many students make mistake, they take x is less than 1 because the power is 1 over 2. If the power is 1 over 2, the first number we must change to 1. Then to find the value of x, we must take from here, which is x power 2 over 4 less than 1. Then from here, we find that x power 2 over 4 is greater than negative 1 less than 1. Then when we shift the 4 to the left or right, so we find that x power 2 is greater than negative 4 and less than positive 4. Since we are not able to solve this inequality directly, so means we need to separate this inequality into 2. That is, x power 2 is greater than negative 4 on the left hand side and x power 2 less than positive 4 on the right hand side. Then we need to solve each of the inequality separately. So for x power 2 greater than 4, when we shift to the left, so x power 2 plus 4. Since we are not able to solve by using algebraically, then we analyze it. We know that all the value of x when power 2 must be greater than 0. Then means x power 2 plus a positive value also greater than 0 for all the values of x. Then as for x power 2 less than 4, we shift 4 to the left, then we factorize. Then from here we will get the range of values of x. Then when we combine these two inequality, then we find that the expansion is valid for x greater than negative 2 and less than positive 2. Now I'm going to use this binomial expansion to find the approximate value of square root of 15 divided by 15. Now when we look at this expansion is done under the power of negative 1 over 2. But when we look at the square root of 15, the power is power positive 1 over 2. So here, before we can apply the binomial expansion, we need to change the power into the same power as the binomial expansion, that is power negative 1 over 2. So here, what we should do here, so here I multiply with square root of 15, Then after I simplify, I get 1 over square root of 15. So here the power is power negative 1 over 2. Then now I compare the value here with the value inside the brackets here. I found that 15 is not approximate to 1. So now I need to separate 15. So here I separate 15 into two values, A multiply B, where A multiply B is equal to 15. Since it is square root of 15, so the value of A, we must choose the value which is square number. So we can choose 4, 9 or 16. Then B is simply use 15 over the value of A. Then when we look at here, we should take the value of B, which is approximate to 1. So means here we will take this one. So now I change 15 to 16 times 15 over 16. So when I simplify, I get 4 times square root of 15 over 16. Now I can compare 1 minus x power 2 over 4 with 15 over 16. After simplify, I get x equals plus or minus 1 over 2. Here I choose x is positive 1 over 2. So now by using the binomial expansion, now I substitute x with positive 1 over 2 to the left and to the right. Now I try to simplify both sides. Then I get 1 over 2 square root of 1 minus 1 over 16 is approximate to 0.51636. Then when I further simplify, then I get 1 over square root of 15 over 2. Then from here, I get 2 over square root of 15. Now I shift the 2 to the right hand side, then I get 1 over square root of 15 is approximate to 0.2582. Now I multiply with square root of 15 over square root of 15, then I get square root of 15 over 15 is approximate to 0.2582. So that's all for today. Do you understand what you learned today? Let me know in the comments below. If you find that this video is useful, hit the like button below. Don't forget to subscribe to my channel. Thank you so much for watching. I hope you keep on learning and keep on watching my videos, and I hope to see you soon. Bye!